This question is about conservation of momentum. So you might remember momentum is mass times velocity would be the definition, and you can think of it as how difficult it is to stop. So things with more momentum are really difficult to stop, and you should know from common sense that something going really fast is difficult to stop, something heavy is difficult to stop. So some quantities are scalars and some are vectors. Which of the following quantities are scalars? So this is just, have you learned your definitions and examples of scalars and vectors? So your quantities displacement is the distance travelled in a particular direction, the total distance from start to finish. Okay, that's a vector because it includes direction, so that is not a scalar. Distance is a scalar, that doesn't include direction. Force, if you push somebody or pull somebody, it makes a difference, that has direction, so that's not a scalar. Speed has no direction, that is a scalar. Velocity is speed and direction, so that's a vector. Difference between vectors and scalars. You could write the full definition and say that a scalar has magnitude, a vector has magnitude and direction, but what it's looking for is the difference, so only vectors have direction. And just a reminder that magnitude means size or how big it is. Bumper cars are a fairground ride and are designed to bump into each other. The diagram below shows two bumper cars moving towards each other. The momentum of each bumper car is shown by an arrow. Give two factors that affect the momentum of each bumper car. So that's very simply taken from the equation. The mass and the velocity of the bumper cars are your two factors. Now we get on to the tricky bit of the question. The bumper cars crash into each other and stop. Explain why both bumper cars stop after the crash. Now the question hasn't cued you to think specifically about conservation of momentum, but because it's already talked about momentum, you should be able to work that out. So they crash into each other and stop. Explain why. So we have to think about what conservation of momentum means. The total momentum is the same before and after the collision. So after the collision, they've both stopped, so that means the total momentum is 0. Because of conservation of momentum, and you will get a mark for that phrase, conservation of momentum, that means that the total momentum of the bumper cars had to be 0 before the collision. That's difficult to explain because they're both moving. But you see that they're in opposite directions. Okay, that will mean one has positive momentum and the other will have negative momentum. So for their total momentum to be 0, they must have both had the same momentum. So before the collision, the momentum of each car was equal and opposite.